Welcome to Summarize Science. Today, we are looking at an incredible new framework called minWM that is changing how we think about AI-generated videos. Currently, most AI video tools take a long time to create a single clip, and you are just a passive viewer of the final result. The researchers behind minWM wanted to change that by turning these models into interactive world models. As shown in Figure 1, minWM provides a complete pipeline to convert existing video generators into systems that respond to user actions in real time. This means you could potentially move a camera around inside an AI-generated scene, just like you would in a video game. The framework is modular, allowing developers to plug in different AI, brains, and training recipes to suit their needs. To make the camera movement feel natural, they used a technique that injects camera parameters directly into the model's self-attention layers. This allows the AI to understand the geometry of the scene so that objects stay in the right place as you move through the environment. By doing this, the AI doesn't just guess what comes next, it actually follows a structured path defined by the user. One of the biggest challenges in real-time video is latency, or the delay before you see the next frame. The team used a multi-stage process called causal forcing to distill complex models into faster versions. This process teaches a smaller, faster student model to mimic the high-quality outputs of a much larger teacher model. By simplifying the math required for each frame, they achieved a significant boost in responsiveness. The results are clearly visible in Table 1, where the speed improvements are truly staggering. For some models, the time it takes to generate the first frame dropped from over 770 seconds down to just 3 seconds. That is a speedup of over 223 times, which is the difference between waiting forever and having a real-time experience. This jump in performance makes these models practical for real-world applications for the first time. In Figure 2, we can see examples of the AI generating consistent worlds while being driven by different camera actions. Whether the camera is panning across a snowy outpost or moving through a fantasy landscape, the visuals remain coherent. The distillation algorithm successfully preserved the model's ability to be controlled without sacrificing quality. The researchers also found that the quality of the training data is absolutely critical. When they used videos with estimated camera poses, the results were often unstable or messy. However, by using accurately reconstructed 3D scenes, the AI learned to follow camera commands much more reliably. They also looked at how the size of the training batches affects the final product. As we see in Figure 5, using a very small batch size often causes the AI to fail at learning how to be controlled. Moving to a larger batch size of 16 significantly improved the stability and allowed for a successful training pipeline. The most exciting part is that minWM is fully open source and supports several popular AI video backbones. This means that the global developer community can now take this recipe and adapt it to new distributions and hardware targets. To recap, minWM is a full-stack tool that turns slow, static AI video into fast, interactive virtual worlds. It solves the two biggest problems in the field: the long wait times for generation and the lack of user control. In the future, this could lead to the creation of infinite video games where every environment is generated instantly based on your choices. We are looking at the birth of a new era of interactive media where the line between video and simulation completely disappears. Thanks for watching Summarize Science, and we will see you in the next one.